Composites are materials composed of different constituents, for example fibers for strength and stiffening properties and a polymer for the load transfer, support and protection of the fibers. Due to this mixture of materials, the options for manufacturing processes are related to these ingredients. First, I will discuss two key features of composites that have a large impact on the manufacturing processes: the type of polymer and the fiber length. The fiber length can be split in three groups: short, long and continuous fibers. Short fibers have a length in the order of millimeters. The length for long fibers is about 10 centimeters, and the length for continuous fibers is a meter or longer. This fiber length has an important influence on manufacturing methods. Continuous fibers can be used for steering the process by pulling of the fibers. Short and long fibers cannot be pulled, so they are too short, so they flow with the polymer. The type of polymer is the other key parameter. Thermoset polymers are made by mixing two or more chemical substances which react and form macromolecular networks. At the start, the viscosity of the mixture is very low, but with time the mixture solidifies, and this solidification is irreversible. Thermoplastic polymers have one chemical substance with long molecules. At room temperature they are solid, and at high temperatures they become soft, though they maintain a rather high viscosity. The heating and cooling are reversible. It can be repeated multiple times. When thermoset and thermoplastic polymers are mixed with fibers, the following can be said. For a thermoset, we should mix two reactive components A and B, both liquids. When mixed, the liquid is used to impregnate the fibers, meaning filling the spaces between the fibers and the fiber bundles. The polymer becomes the matrix surrounding the fibers. In the next step, the chemical components A and B react and create macromolecular networks and molecular bonds. The polymer solidifies. The time between mixing the chemicals A and B and the moment the polymer achieves a specific solidification level is called the pot life, the process window of the polymer. Thermoplastics are solid at room temperature and don't react chemically. The long molecules in the substance can be disconnected by heating the polymer. At that temperature, the polymer and the fibers are mixed. Since the viscosity of the thermoplast remains high, different methods are invented to get proper impregnation of the fibers. Examples are using a solvent in the polymer to lower the viscosity, mingle the fibers with thermoplastic powder, and using polymer fibers mingled with the real reinforcing fibers. The other key feature is the fiber length. Short fibers cannot be controlled or oriented in the matrix. The effect of such fibers on mechanical properties like strength and stiffness is limited. Usually, short fibers added to a polymer may increase strength and stiffness values with a factor of 5 to 10. So the E modulus, for example, goes from 4 to 30 or 40 gigapascal. Composites with short fibers are also more stable at high temperatures. The properties don't decrease as fast. Another feature of short fibers composites is that they are more or less isotropic. The fibers are oriented in random order. Continuous fibers can have a large effect on the mechanical properties. The strength and stiffness values can be 100 times larger than the polymer values. These fibers are oriented in specified directions for the optimum effect. In doing so, tailored materials and structures are created, exploiting the excellent mechanical properties of the fibers. Merging the two key parameters results in the following table with manufacturing methods for composites. I will briefly mention each process. A few are explained in more detail in following slides. The combination of thermosets and short fibers is hardly used in aerospace. Problem here is the long cycle time of thermosets. The combination of thermosets with continuous fibers is used extensively. First, in all hand layup of dry fibers or of prepregs. Prepregs are fibrous materials already impregnated with the right amount of polymer. When dry fibers are laid up, a subsequent process can be the vacuum infusion process. By applying a vacuum, the resin is forced through the fibrous material. Resin transfer molding is another infusion process, using matching dies, and is able to apply pressure to force the polymer into the die cavity, which is filled with fibers. The next processes are filament winding and tape laying by robot. This will be discussed on the next slide. The last process is pultrusion. A large number of rovings is pulled through an impregnation bath and through a die set that shapes and pre-cures the product. When cut to the right length, the product needs a post-cure. For thermoplastic composites, the manufacturing methods are injection molding involving short fibers. This process can be fast because of the rapid heating and cooling of the polymer. During injection, the fibers drift with the polymer flow. For continuous fibers, often a flat laminate is used as a semi-finished product. By heating the laminate, the polymer becomes soft again, and, for example, banding or press forming can be used to shape the product. Finally, filament winding and tape laying are also options for thermoplastic composites, although not used widely yet.